Figure 2-4, Ethernet switching. In this example, we are talking just about switching within the Ethernet LAN. Subsequent figures, subsequent material will talk about switching between LANs. Here we have host client F2 that has an Ethernet frame which it wants to get to destination A2. Our question is, of course, what path will it take to get there, and what impact or what changes occur in switch forwarding tables, what content will they have based upon the configuration of the network. So let's start. We have host client MAC F2 connecting up to switch A of our local area network. It connects to port 1 on switch A. Let's add the next connection that we're interested in. Switch A connects its port 4 to switch B port 5. Now today we don't normally connect switches in ports this way, but it can be often done. However, for our example, using port numbers on switches will illustrate some important points. So again, switch A port 4 connects to switch B port 5. We also see on switch B that we have port 16 connected to client host MAC B4. What effect does all of this have on the switch A forwarding table? Well, the switch A forwarding table has, as all forwarding tables do, a list of MAC addresses and a list of associated port numbers where those MAC addresses are connected or where they're known to exist. We look, F2 in this forwarding table is connected to port 1, and B4, A2, and D2 are connected somewhere out switch A, port 4. Switch A, remember, like all switches, is a passive device. It brings things in bit by bit, recreates a frame, examines the frame header, and looks at the source and destination addresses. And for the purpose of switching out of its switch, it takes the destination address and sends things out to the appropriate port. In our example, we're trying to get to A2, so when switch A has that frame that it's analyzing, it will send it out port 4. Port 4 will get it to switch B. Switch B will then have to make a decision what it does with that frame. Let's add another switch. Switch B, port 12, connects to switch C, port 16, so that we have an interconnection there. Let's take a look now at the switch B forwarding table to see what's going on. Switch B knows that F2, if we look back towards switch A, it knows that F2 connects somewhere out port 5. It knows that MAC address B4 is connected to port 16, but it also knows that A2 and D2 are connected somewhere out port 12, which happens to be connected to switch C. So let's continue and add some more devices. Switch D comes in, and we find that switch A, port 11, connects to switch D, port 9. What does this mean for the switch C forwarding table? Well, switch C knows that F2 and B4 live somewhere out or connect somewhere out port 13 of itself. And it also knows that A2 and D2 connect somewhere out port 11 of itself. Let's add a couple more devices. We have host server MAC A2 and D2. A2 connects to switch D on port 4. D2 connects to switch D on port 5. What impact does this have on the switch D forwarding table? Switch D knows that F2 and B4 are connected somewhere out port 9, and that's because port 9 is what connects switch D back to switch C port 11. But it also knows that it has two devices that are connected to ports 4 and 5. That's A2 and D2 respectively. So the question becomes, or the question will answer, what path will it take to get a frame from host F2 to host A2? So let's follow this through. Host F2 sends its frame to switch A, port 1. The switch must then make a decision, and it will examine its switch A table, and it will send a destination of A2 out port 4. Port 4 connects to switch B port 5. Switch B will take the frame in, it will examine it, it will determine that destination address A2 connects somewhere out port 12, so it will propagate that frame out port 12. It will go into switch C, port 13. Switch C will make a decision and send that frame out port 11. It will go in switch D, port 9. Switch D will make a decision saying, yes, I know that A2 connects out port 4. It will then send that frame out port 4, which in our example happens to be directly connected to MAC address A2 for that host server. Switches don't know that, but they do know that they need to send the frame out a particular port. It is the responsibility of the receiving device, the host in this case, to process the frame appropriately. And in this case, that means to decapsulate and to do something with the frame on the host.